Good morning and welcome to Session 7. In today's discussion, we're going to start with quality. Quality, as we've talked before, is based on the voice of the customer. How do you hear it? What are the ways you are hearing it? How can you hear it? In other words, what's out there and what are you taking advantage of? Are you really listening and how do you really know? Voice of the customer can be a very tricky thing. The classic U.S. capitalist model says the voice of the customer. People talk with their money. Your sales go up, that means your customers are happy. Your sales go down, that means your customers are not happy. But there are a lot of other aspects. We've all been through this. Different customer surveys, people calling you up afterwards, or texting you, or sending you an email saying how was the service. And there are a lot of direct feedback methods as well. So, at the example of a restaurant, the server comes up to you and says, "How's everything going? Was your food good?" Whatever. Maybe the manager stops by. So there's a lot of different aspects of the voice of the customer that you can take advantage of. Quality, again, is defined by the customer, linked to profitability, as we said, and as a competitive weapon. So if your company's quality is better than all your competitors, well, that's an advantage. Now, of course, you got to look at what your strategy is. If quality is your strategy, that's great. If low cost is your strategy and your cost is higher because of quality, well, then you got to make that decision. And again, this is integral to your planning and an organization-wide commitment. So if you're going to have good quality, everyone has to be involved. It can't just be, we used to always say that quality can't be tested in. It's not just the quality department's job, it's everybody's job. And you'll find that if you want to have good quality, it's got to be added every step of the way, including management, design, all the process associated with creating the product, all the way through the entire organization. So, contributes to a competitive edge. Achieving operational excellence requires major emphasis on quality. In other words, if you have bad quality, you can imagine how poorly your operations might run. If you have a forecast and you say that you need 100 units a day, but your process has bad quality, so one day, you built 100 units, but only 90 of them were functional at the end of the line. Or maybe your vendors, your suppliers are not good quality, so you order 100 parts, you get them in, maybe the order's short, maybe the bad vendor quality is because they didn't ship the right quantity. Or maybe you get the product in and you open up the box and find that some of the equipment's damaged or some of it's such bad quality you can't take advantage of it, you can't use it. So again, you can imagine how your operation would kind of go up in the air every time something like this happened. Never an accident, always the result of intention, effort, direction, execution. And again, represents the wise choice of many alternatives. Well, you've just been through the second of the two simulations, and you know about the idea of wise choice of many alternatives. And quality is the same way. A lot of times you'll sit in a situation where you've got a proposed product design change, and the belief is that this is going to reduce the cost, maybe improve throughput, but you have to ask yourself, what's the impact on quality? If I, decision A versus decision B, which one's going to give me the better quality? Is it sufficient based on the other offsetting factors? So, maybe I can get better quality, but maybe the cost is too high. We saw this with a lot of companies when the big push for Six Sigma was prevalent especially among manufacturing companies. You'd sit there and say, okay, I think I can take another, 0.1% out of the defect rate of this product, but it's going to cost me this much money. And a lot of companies had the, shall we say, the goal of top quality at all costs. So the idea was that, if you went to your boss with an idea that would improve quality pretty much regardless of cost, they would implement it. The problem with that is at some point you reach that tail end where it's harder and harder to find quality improvements, and each one incrementally costs that much more. When you're down to, the 1/10,000th of a percentage of a defect rate, and you're trying to cut that in half, that's pretty difficult to do. So again, you have to make wise choices and look at the full technical analysis before calling the shot. There are two types of quality: product, service, and process. Again, the end result is a good product, a fine product at the end, but when you're done, you have to have a good process to support it. Again, this is the idea of I can't test in quality. If I want to have quality product, I have to have a good process supporting it. If I have bad quality, what can happen? I can have liability, I can have problems with the reputation and lost opportunities. So liability, you can have legal expenses. You see, if you watch television, you see all the time the ads for lawyers. If something ever happened to you, please call us. And but the fact of the matter is that if you design and deliver a bad product, people may get hurt, people may die. We've seen cases with the auto industry where some very severe things have happened. And so as a result, there's liability for that. If you design a product that, especially if you know it's defective or you think there's a probability that it could cause a problem, that's a real issue. Company reputation, it affects you, your suppliers, your employers, and your customers. For example, we had some tire recalls in the past, and what would happen? Well, it had a negative effect on the tire company, but then when the tire company had that problem, their sales went down. That affected their suppliers. Their suppliers' sales then went down. And then ultimately it affected their customers, because the auto companies that used those tires were affected negatively and many times switched to another company. And so that's a problem. And then finally, lost opportunity. There's a cost associated with all this. If you have a recall, that's a very expensive process. Finding the problem, tracing it back to a particular lot of product, hunting down that product, replacing it, especially if it's in the hands of the customer, maybe paying for a service call to repair or replace an item. That's very, very expensive. And that's money that could be spent on other things like sales, developing new products, a new factory, a new piece of equipment, additional employees. So again, the impact of negative quality is far-reaching. The evolution of quality, we started off with quality control. This was the old one. You'd see this in clothing. You'd find a little paper tag that said inspected by number 4 or something like that. And this is the idea of inspection. So I've got product. At the end of the line, I look at it. If it looks good, it goes to the customer. If it doesn't, it's rejected. The problem with that is it's a very limited approach. And if you want to really evolve in the quality process, you want to look at quality assurance. Again, focused on the needs and the expectations of the customer. So quality can be a pure function in and of itself, but oftentimes, from a business standpoint, you want to drive quality off of the customer's requirements. So you know what the customers want. They want a certain thing to work a certain way. They want a certain size, a certain color. If you're selling cars, you want it to have certain mileage. You want it to function. You want it to work every time. And so you have to have a prioritized set of needs from the customer and then drive your requirements for your quality organization around that. So if your number one goal for your customer is dependability, how are you going to test dependability? It's not easily tested coming off the end of the line. Maybe you take products and sample them and run them on a test track or something like that. But the whole idea here is, again, it's got to be driven off of the customer's requirements, and then driving the processes that support it. So this goes back to the whole concept of I find a defect, I prevent the defect. So if my number one goal for the customer product is, so for example, I don't know, on a car, you want to get to certain miles per gallon. Well, you test your cars, find out what miles per gallon they deliver, and then you look at it and go, okay, what are the things I can do to improve that? Reduce weight, improve the computer software that drives the fuel system, maybe improve the fuel injectors, whatever. What are things I can do to make sure I get to that number? Because when I test, I'm going to have a little bit of variability. Some cars are going to be a little better, some cars are going to be a little worse. That's just the nature of things. So I want to make sure that range, I want to minimize the width of that range and make sure that at worst case, it's still better than my goal. So this is kind of the idea of how do I ensure quality. And if I have a good process that's under control, I can minimize the variability and have a good feeling that I'm delivering good quality product to my customer. And then I look at different quality management overall approaches. You may have heard of some of these, like ISO, TQM, Six Sigma, and different things. These are all overarching business processes that touch everything. So if you're going to have a Six Sigma product or a TQM product, this means that every step of the process, things like the equipment, the maintenance, the quality of the inbound goods, the quality of your supplier processes, the quality of your delivery processes. So, this covers the entire gamut, the entire supply chain that you have to look at. And so this is a very daunting task. And again, you have to have good partners to work with, at your supply side and on the delivery side. You can build a really good product, and if it gets busted up every time it gets delivered, well, that's not going to help you much. Key terms in the quality space, we talk about total quality management. Again, the idea of end-to-end process control, management, and a quality focus. PDCA, plan, do, check, act. So again, this is the idea of continuous improvement. So planning, I've got a plan in place. I build the product, for example, and then I check the product, I inspect it, I test it, and then I act. And basically I'm acting based on those results of that testing. So if I have good results, I ensure that I have a good process and keep it under control. If I have issues, I take steps to make improvements. And then Kaizen is a Japanese word for the ongoing process of incremental improvements. Again, the whole idea of Kaizen is that I can make a lot of little improvements, things that are not massively expensive. So I can tweak a machine, I can buy a little better tool bit, I can add a little training to my team. And in these small incremental ways, I will drive up overall quality. Six Sigma, you may or may not have heard of. Again, this is an idea of Six Sigma that I get to 99.9997% accuracy. In other words, if you're a statistical person, you understand the idea of the bell curve, and I have different variability, and Six Sigma basically says that within Six Sigma, I'm going to be good. So basically what that translates to in practical terms is 99.9997% of the time I'll have good quality product. And as you can imagine, that's a pretty daunting task, tough to do. So again, an interesting approach and another way to drive overall quality. Statistical process control is the idea of taking action as things are going on. So I don't wait for defects. I'm monitoring activity. So for example, I'm measuring a certain component. And if the component is supposed to, I don't know, pick a number, have a certain size of a precision hole that's drilled into the product, I measure those holes. And I take action before they get out of spec. So in other words, my spec has to be wider than what I'm actually delivering, so that if my standards, the actual measurements start to vary too much, I can take corrective action before things go bad. And so a lot of ideas, we had bracketing, we had trend lines, we had fault lines, limit steps, various terms used for this. But again, the whole idea is to continuously monitor the process. And as things start to vary, watch that variation and take corrective action when it reaches a certain point. But the idea is that that point is before I have defects. So maybe I have twice as much variation as I'm used to, but I'm still within spec. So the whole idea is I never create a defective product, but I'm still managing my process proactively to make sure things are good. And then finally, employee empowerment. The idea here again that quality and good process control is everybody's job, and so from the people on the factory floor all the way up to senior management, everybody has to be involved. So a little more detail on Six Sigma. The whole idea is, again, I have this statistical variation. So we know in reality everything varies, and oftentimes, not always, but most often, things vary in a bell-shaped curve. So the whole idea is if I have a target, my goal is right here, I'm going to have some variation. With standard 3 sigma is what was used typically in industry. What that meant was that 6.6% of the time I would be producing a defect. Here I have 6 sigma, and here I'm producing no defects. Is it no defects? Technically not, but it's that very, 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 very small percent likelihood that I'm creating a defect. So if I can get the statistical curve, and what you see in the two diagrams, you can see, if you're paying attention, two subtle differences. One is I've made the target further away from the customer specification. So you see the target line, you see the customer specification. So I've got those, and so here my target is too close to the customer specification. As a result, part of my curve is out of spec. In this case, however, I've moved them a little further apart, and the other thing you see is I've narrowed the width of my bell curve. So by narrowing it and by moving away slightly, I've managed to get a much higher percentage of product to be within spec. And this is the basic foundation of Six Sigma at a very high level. So other Six Sigma elements, DMAIC, similar to what we talked before: define, measure, analyze, improve, and control. So the whole idea is I define what's going on, I measure it. Am I making my specs? Is my process under control? I analyze the data. I come up with improvement plans, and then I control things. So again, I may not need improvement as long as I keep things under control, or I may need the combination of both. I've seen too many cases in business where I've seen the same problem resolved many, many times. I can point to several cases of, in fact, one case where I saw it resolved 5 times. And what I mean by that is a bright person comes up with an improvement to the operation. It's going to improve quality, it's going to reduce cost, it may even improve cycle time. We implement it, and all of the above is true. It was a great idea, good thing, make it happen, that's fantastic. And then a while later, maybe a year, a couple years later, another bright individual comes up and says, hey, I got this great idea, blah, 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 blah. It's going to save money, it's going to improve quality, it's going to reduce cost. Let's take a look at it. And lo and behold, it's the same suggestion that the first individual had suggested, but problem is that along the way we lost control. We quit doing it. We quit using that new approach. And so over time we returned back to the way things used to be, which is kind of what happens in a lot of processes. So you have to, manage the overall process, and control is a big deal. So nobody likes doing it. Nobody likes doing control. Nobody likes to sit there and make sure everything's on track. It's kind of boring. It's more fun to come up with great new ideas and implement them. But control can be a very important part of your process. You're going to reduce process variation, and again, you're going to get more consistent yields. So it's often said that it's more important to be consistent than good, and somewhat that's true because, again, if I'm consistent, then I can do forecasting, I can do improvement plans, whatever. If things are inconsistent, it's very difficult to manage the process. And again, if I get good operational efficiencies, so if my processes are good, I'm going to predict output based on input. Simple example, if I don't have much scrap coming out of my process, if I put 100 units worth of material in, I'm going to get 100 units out the other end. If I have an out of control process, who knows what I'll get? It certainly won't be 100. It may be, maybe less, maybe much less. Again, depending on the quality of my process. So again, the whole idea is I want to get better improvements of my business process a lot of different ways if I have good operations. Challenges in quality, customer satisfaction. What is the level of quality improvement needed? How steep is the hill? Or for lack of a better term, how deep in the valley are you? So again, if I have very good quality, I'm all the way to the left here, I may not need much. Maybe there's nothing I can do. Maybe I'm the industry leader. Maybe people are coming to me looking for ideas. Again, I get a little further down the pipe, increased effort initiatives. Again, this is that whole concept of that the Kaizen, where I have incremental improvement. A little incremental improvement, a little attention to detail, maybe a little better control, and life will be good. It'll get me closer to this ultimate. If I'm over here on the right, I may have to have a significant course correction. And what that means is incremental improvement isn't going to get me where I need to go. I may have to buy major new equipment, go to a whole new process, use automation instead of manual methods, change the raw materials I'm using, go to a different parts supplier because I can get a much better quality product from somebody else. Major hiring of different people, get a more highly skilled staff on board. You name it. But again, you have to decide where you're at and where you want to be. Very simply, if I'm building pacemakers or if I'm building screwdrivers, well, I think the quality and the attention to detail may be a little higher with pacemakers. You decide. I think it would be if it was my choice. So the whole idea comes down to is you start off with your requirements and your strategy and say, hey, look, here's where I need to be. Then you look at your process and the quality of your products and go, where am I? If I'm close, I can go with incremental improvement. If I'm there, I'm done. I just have to keep things under control. But if I'm a long way away, I've got to look at some significant changes to get me where I need to go. So when I look at turnaround actions, so again, this is that thing over on the right where I've got to make major changes. I can focus on the organization, build the right team, execute the right projects, and provide the right tools. So again, focusing on the quality targets, again, how do you do this? And the biggest thing is metrics. I have to measure. If I can't measure it, I can't tell you where I'm at. I don't know where my quality is. Am I good? Am I bad? Am I meeting my customers' expectations? Am I not? Don't know. Have to have metrics. And this can be very, very difficult. And a lot of times it's been said that the type of metric or your selection of metrics is going to drive where you're going to go. It's going to drive the direction of the organization and what's going to happen next. And one other comment here is you see the term bulletproof metrics. The whole idea of bulletproof is that I can put something in place and I can measure it consistently, and everyone agrees that that's measured correctly and that the metric directly ties to my goals and my expectations. So again, a little more discussion on metrics. When we have the right metrics and we have everyone working towards those goals, and assuming those metrics are aligned with our customer needs, we're going to see a greater customer focus. We're going to see people understanding what the customer needs and doing the right thing towards those customer goals. We're going to see improved quality, process cost reduction, cycle time improvements, reduced waste, better products and internal processes. And again, we can use metrics to drive performance reviews and other action plans. Customer-centered metrics. Who's your customer? What do they expect? And then finally, how do you measure against those expectations? It can be very difficult sometimes to do this last one. One of the issues that we see with this third one is how do you measure? Because you typically have a disconnect between what's easy to measure and what you want to measure. So for example, think of a restaurant. You want customers to be happy. You want them to love the food. So how do you measure that? Well, what can you measure? Can you measure if the food is good? Not directly. You can do taste tests and things like that, but the individual plate leaving the kitchen going out to the customer, can you measure the quality of it? It's not easy to do. You could measure the temperature of the food. You could measure how long it takes you to get the food from the kitchen to the customer's table. But customer satisfaction, what they're truly happy about, especially in the service industry, is not always easy to determine. Call center example. We all love and hate call centers. These are the people you call, and you want help. Typically, the IT help desk might be an example of this. And so, how do they typically measure call centers? How fast they answer, how long people are on hold, call abandonment rate. Call abandonment means that the customer hangs up, for lack of a better term. And then escalation rates. How often does the customer get frustrated and say, hey, let me talk to somebody higher up, let me talk to the boss, whatever. So when you look at this and you go, well, what does the customer want? Well, they want their answer. They want their solution. If they have a problem, they want it fixed. If they have a question, they want the correct answer. And if you look at this, you go speed of answer, on hold time, abandonment rates. Well, if you think about it, the last two, call abandonment and escalation, are probably the closest link to customer satisfaction. Speed of answer, on hold time, for example. Speed of answer is something that's often used to measure the effectiveness of a call center. So if you think about it, if you're the boss of the call center and you've got 100 employees sitting there answering a phone, you've got a certain call volume, well, what do you want to do? You want to have as many calls as humanly possible solved by the call center. Well, speed of answer is important. So the idea here is if I get the call, get the person off the phone quickly, that means one or two things. Either I'm very, very effective at giving them their answer, or I kind of shut them down and really didn't listen, didn't give them much time. And that's been a common complaint about call centers is, they're not interested in solving my problem, they're interested in getting me off the phone. And so again, it can be a tricky balancing act. Some of my best call center experiences have been times where I had a problem And the person stayed on the line the whole time with me until I was able to change it. In the past, I'd sit there and go, hey, well, try this and call us back if that doesn't work. But I've had other cases where it's like, well, no, I'll wait online on the phone while you try it, see what happens. And that, to me, is a much better service. So, again, just an example of trying to tie out appropriate metrics to what the customer really, really wants. So, turnaround actions again. How do we get to the, how would you improve quality in your operation? That's kind of up to you. You have to decide where your organization is, what different things or actions you might take that are going to improve the quality of your team. Cost of poor quality, or COPQ. Cost of poor quality is a common term. A lot of quality organizations are measured on it. They look at the cost of poor quality and they expect that, hey, I'm making a certain investment in quality improvement. I expect the cost of poor quality to be improving over time, as an outcome of that investment. So the definition, the cost of doing things wrong, that is the price of non-conformance. And it's associated with prevention, discovery, resolution. One product return a year could be a cause for concern. The biggest cost of poor quality is the image of the product and the company. So this can be the entire range of things. So it's not just the cost of the quality team. This is the cost of everything wrapped around bad quality. So for example, if I have to add a bunch of testing stations that I wouldn't normally need because I have poor quality and I have to try and stop it, that's a cost of poor quality. If I've got technicians in the field doing install work and it takes them longer because the product is inconsistent, well, that's a cost of poor quality. And then finally, if I have a recall and it's spread all over the news and I lose sales because of it, or I lose customers because of it, that's a huge cost of quality. Major categories: planning and execution of prevention, appraisal, internal failure, and external failure. So again, prevention, that's pretty obvious. Putting more money into the design, putting more money into the better quality products. Appraisal, that's the whole testing thing, measuring, evaluating what's going on, assessing the quality of my processes and my product. And then internal failure, that's something that fails inside the house. In other words, I build 100 items and one of them is dead before I ship it, and I've caught it because of my internal testing. That's not a good thing, but it's far better than an external failure. That's where the customer finds the problem. When the customer finds the problem, now you have that issue of reputation. You have the issue of, what do I do with it? How do I deal with a customer problem? Do I send a technician out to fix it? Do I send them a free one? What is my total impact of having an external failure? So this whole network ties together the cost of quality. And interesting, you wouldn't think there would be a cost of good quality, but again, the cost of good quality is tied to appraisal and prevention. So this is, I'm not making defects, I'm preventing them. And so the cost of good quality is tied with my appraisal, my prevention. And then cost of poor quality is where I have failures. I have an internal failure or an external failure. And the idea of an ounce of prevention is worth a pound of cure. This ties out to this model as well. This is just an example. Order of magnitude, it's typically correct. Preventing an internal defect is $1 versus $10 to find and fix it internally, $100 plus to find it and fix it externally. So again, the whole idea is $1 to prevent it versus $10 to correct it internally versus over $100 to correct it externally. And this should be fairly obvious. When we had processes, for example, that we couldn't truly assess the overall cost, we just used these numbers. So for every internal prevention item, I had $1. For every internal failure, I had $10. So if I had 100 of these, I'd have $1,000 of cost. It might not be something you can directly point your finger to. So if I can make these go away, where's that $100 come from, or where's that $1,000 come from? That's not always clear, but these are meant to be order of magnitude estimates to help drive my decision-making process. Next topic I want to talk about is human resource strategy. The whole idea of looking at your people. Often said your most important asset are the people who work on the team. The management folks, people on the floor building product, the salespeople, the engineers designing the product, what have you, technicians doing maintenance. And again, how do you do this effectively? So It's good that this follows after the quality discussion because an awful lot of your quality results depend on quality people. So how can they be effectively utilized within the constraints of other decisions? And people should have a reasonable quality of work life and an atmosphere of mutual commitment and trust. We touched on earlier that in the quality discussion, that quality has to be something that everybody does. And again, you have to have a good atmosphere in the organization if you're going to have everyone involved in good quality of steps. So it's all part of the overall model of tying things together. When we look on the human resource strategy, it has to be tied to everything. What is your product strategy? Starting at the upper left. So what do I need? Do I have a heavily automated factory that doesn't require a lot of highly trained people at the assembly level, but then requires highly trained people as technicians to keep these things going? Safety is always often an issue tied to the product strategy. Schedules. When is my factory operating? Time of day, time of year, is it seasonal? And how stable are these schedules? So I would think of the example of seasonal work. What if your forecasts are wrong and all of a sudden you got to tell everybody to take the rest of the day off because you don't have enough work to do? Or you have to ask them to work all kinds of overtime because I have too much work to do. Location strategy, the climate, the temperature, the noise, the light, the air quality. A lot of us are lucky to have worked in fairly nice office environments, but a lot of folks don't have that opportunity. So some product activities are noisy, are hot or cold. Think of a meat packing plant. You're working in a freezer all day. Amount of light, air quality, etc. Process strategy, the type of equipment used, individual differences. You can think about it from a physical standpoint and also from an intellectual standpoint. Everybody's different. Some folks are going to be stronger at certain things, some are not, and then you have to look at that and go, well, how do I mix and match the folks to get the right people aligned to the right jobs? And then layout. Do I have fixed positions? Do I have an assembly line? Do I have a work cell type approach? So all these things are going to contribute to my human resource strategy. Core job characteristics. Now this is something of a subject that I think a lot of people will debate. One of the common beliefs is that for people to be happy, successful, content, solid members of the team on the job, you want to have skill variety, job identity, job significance, autonomy, and feedback. So skill variety means I'm just not doing the same thing in and out every day, every day, every day. Job identity says that I get some personal pride off of this. I'm associated with that job. I can look at what I've done at the end of the day and go, wow, I made a difference here. And that links up to significance. I personally had a summer job one time, and there were several of us working in an area, and different people did different amounts of effort. Some people worked very hard, were very thorough. Some people didn't work hardly at all. But the interesting thing was, at the end of the day, everybody got paid the same. The product that everyone built all went out the door, regardless of if it was done with effort and integrity or if it was just done sloppily. So at some point, the job significance really dropped because it kind of came to, well, you can do a really good job, and other than personal pride, there's no feedback in the process that says, that your work is valued. And then autonomy. How much freedom do you have? How much freedom do you need? How much freedom is appropriate? If you're working in something that is a very sensitive area that requires very high degrees of care and quality, maybe you don't have that much autonomy. Maybe you don't have that much freedom to pursue different approaches to the process. And then finally, feedback. What kind of feedback do you get? Do you get feedback from the management? Do you get feedback directly? Feedback from directly is, you put something together and test it, and does it work or doesn't work? That whole thing as far as feedback. So we think in terms of the job design continuum. The whole idea is that on the lower left you have highly specialized tasks, to the upper right where you have self-directed teams. By that we mean highly specialized means that you're a specialist, one in a million technician the only person who can do a certain job. At self-directed teams means that we have a task or a series of tasks. We've got a team of folks, and pretty much everybody on the team can do every task. So it's kind of a team effort. Whoever's available, whoever's handy does the job. So not highly specialized. And so you can look at this and think about, the expectation is that everyone's striving to go to the right, but that's not necessarily true. There are people who are specialists. They don't want to do everything. They see what they're doing as critical and important. So again, although there's a belief in some circles that this is the right direction, you want to progress to the upper right, it's not always the case, and it depends on the function. If I'm having critical surgery, I want a specialist. I want somebody who knows how to do this, does it day in, day out. I don't want a self-directed team of people where everybody's just kind of like loose, and whoever does it does it. Again, depends on what you're trying to do. Now, I admit that I know surgery, for example, requires teams of people, but again, I'm looking for some specialization in that space as well. So in summary, we've talked about managing quality, the Chapter 6 content, layout strategies, human resources, job design, and work measurement. So again, wish you all a great weekend, great week ahead. And again, as always, if you have any questions, reach out to me anytime. Take care, folks.